Hello students. So we have discussed just through the introduction of bonding. So bonding is nothing but an electrostatic force of attraction that we have discussed. Then we also explained the formation of ionic bond and covalent bond, and also differentiate the characteristics of ionic bond and covalent bond. So right now we discuss a very important concept, that is Lewis formula of molecules and polyatomic ions. That is called, or you can say it is also called your Lewis electron dot structure. Lewis electron dot structure, and few steps are there. These steps are not applicable to all the polyatomic ions or molecules, but these are some procedures, general procedures for the attempt to draw the Lewis electron dot structure of molecules and polyatomic ions. Okay, so first step 1, that is step 1. Write down the skeleton of molecule or polyatomic ion by placing the list electronegative atom at center and other atoms as combining atoms. But remember, hydrogen and fluorine are always present at terminal positions. Next step, calculate the total number of electrons present in the valence shell of all the constituting atoms. Next step, or you can say in case of add the required number of electrons equal to the unit negative charge present in an anion while subtract the number of electrons equal to the unit positive charge present in a cation. In a cation. So the next step you can write. We will discuss all these steps through examples. Okay, don't bother about that. So step 3 you can write, join all the atoms in a molecule through electron pair. Join the atoms in a molecule through electron pair in between them. Thereafter place the other electron pairs, you can write other electron pairs through intelligence such that every atom having 8 electrons in their valence shell. Okay, so let us proceed through examples. What are these steps? Let us consider water molecule, H2O molecule. Okay, so first you write down the total number of valence electrons. First you write down step 1, skeletal equation, skeletal formula you can write. Skeletal formula, out of hydrogen and oxygen is more electronegative and hydrogen is least electronegative. But here we have already, there is information that hydrogen always present at a terminal position. So 2 hydrogen atoms are there. So compulsory 2 hydrogen atoms like this, and the central position is occupied by oxygen atom over here. Now just calculate the total number of valence electrons. Step 2. The total number of valence electrons for 2 hydrogen atoms, 2 plus for 1 oxygen atom, that will be 8. So total that will be 10 electrons. So 10 electrons means how many pairs? 5 pair of electrons. So it's compulsory. First you just place one pair in order to attach all these elements. Then the remaining, there is 3 pairs of electron remaining. 2 we have used and 3 pairs are there. So that can be arranged like this. See, 2 pairs. So we have to calculate the total number of valence electrons. So here hydrogen having 2 plus for oxygen the number of valence electrons, that is 6. So total will be 8 electrons, and this 8 electrons you can write 4 pairs. Okay, now 2 pairs we have used and another 2 pairs remaining. So these 2 pairs we have to adjust so that each atom having their nearest inert gas configuration. So in case of oxygen, you just see the next 2 pairs are there. These 2 pairs can be arranged over here like this. Okay. Right now you can calculate for oxygen atom 2 to 4 to 6 4 to 8 electrons, and hydrogen having 2. So the overlapping is like this. Sorry. So here H, O, H and 2 pairs of electrons are there. These 2 pairs, since they do not participate in bonding, you can assume these 2 two pairs of electron as lone pairs, and here these two pairs are called bond pairs. Okay, and if I ask over here, what is the covalency of oxygen and hydrogen? As I have told you, the number of electrons contributed. Here oxygen, how many electrons it contributes? 2 electrons. That's why its covalency is 2. Or you can very simply you can remember the number of covalent bonds corresponds to its valency. So oxygen, how many bonds are there? 2 bonds are there. That's why the valency of oxygen you can consider 2 and hydrogen 1. Is that clear? So next, another example I can consider over here, that is, let's say I am very simple example. Let's say you do it for CO2 molecule, carbon dioxide molecule. So the skeletal equation, carbon is less electronegative at center, and oxygen, 2 oxygens are more electronegative lying at terminal position. Then you calculate the total number of valence electron, TVE I am writing over here. So for 2 oxygen atom, that will be 6 plus 6 plus for 1 carbon atom 4, that will be 16 electrons. Okay, 16 electrons means how many pairs? 8 pairs. So 8 pairs before I can place over compulsory to connect all the atoms of pair of electrons I applied, then remaining 6 pairs are there. And now these 6 pairs you have to maintain your idea so that every species can achieve 8 electrons. Okay, how can you do this? Just see, oxygen, there are 6 pair electrons, carbon already 2 pairs, 4 electrons, then 6 pair I can arrange like this here, 1, 2, 3, and I can over here 1, 2, 3. You see, if the situation is like this, then this oxygen having 2, 2, 4, 2, 6, 8, these 2 oxygen having 8 electrons, but in case of carbon it is associated with only 4 electrons, then it need 4 electrons. Okay, so if the case is like this, so what we have to do, we can make a double bond here and we can make a double bond over here. Here you see, if I connect these two, right now you see carbon is associated with 8 electrons, and each oxygen also 2 to 4 to 6 to 8. So this is the structure of a carbon dioxide. You can do like this. Okay. So next, suppose I am considering a polyatomic ion. Right now we should consider a polyatomic ion. Polyatomic ions means, say, let us consider in case of CO3 2 minus. So first you calculate the total number of valence electrons. Total number of valence electron for 1 carbon atom I can write over 4, plus for 3 oxygen atoms you can count 18. And since negative ion is there, 2 negative is there, you just add 2 for that 2 electrons. So here total will be 14 electrons. So 14 electron means how many pairs? 2 pairs. That clear? Next, write down its skeletal equation or skeletal formula. That will be sent least electronegative, that is carbon, and 3 oxygen can be arranged in this way. Clear? Now you can place pair of electron among them. Now 3 pairs you have used, so the next remaining, that is 9 pair of electrons are there. So 9 pair of electron you can arrange like this. 3, 3, 6, and like this. Okay, so how can you do its structure so that every species can get 8 electrons among them? Is that clear? So carbon, you can, here each oxygen associated with 6 electrons, but carbon 6 electrons are also there. So you can do like this here, you can make a double bond over here so that carbon can achieve, here you see these 2 electrons and these 2 electrons can make a double bond like this. Okay, and 2 minus is there, that means this carbon, and here will be like this. Now you see this carbon is associated with 2 to 4 to 6, 8 electrons, and each oxygen also 8 electrons, 2 to 4 to 6 to 8, 2 to 4 to 6, 8, and here also 8 electrons. But provided these 2 oxygens get negative charge, you can mention a 2 negative over here. So this is the structure of carbonate ion. Structure of carbonate ion. Clear? Next, if you need to do the structure of, let's say, ammonium ion, I am saying ammonium ion, that is NH4 plus. That clear? So its skeletal equation can be written as NH H. That clear? Next, mention the valence electron, total number of valence electron for nitrogen. The number of valence electron, that is 5. For 4 hydrogen, that will be 4, and a positive charge is there, you can subtract -1, that will be 9 minus 1, that is 8. Okay, 8 electrons means how many pairs? 4 pairs you have to use over here. So compulsory, you just connect these 4 pairs with the surrounding of nitrogen atom. Okay, so nitrogen having 5 valence electrons, so you can connect this one, one pair electron, one pair electron, one pair electron. These are 3 pairs, and you can mention a 4th pair electron over here. You see this 4th pair, that is nitrogen having 3, 2, 5. Is that clear? And for 8 electrons, what you have to do? There is a formation of a coordinate bond. You just do simply like this. Okay, 4 pairs are already being used. Nitrogen is associated with the 8 electrons, and each hydrogen atom also associated with the 2 electrons. But what happens here? You have to place a positive sign over there, because NH4 plus is formed NH3 plus H plus without any electron. This is called proton. So nitrogen donates this pair of electron to hydrogen to form NH4 plus. So here this bond is formed, this pair of electrons particularly from nitrogen atom. So this is the structure of ammonium ions. Okay, so likewise you can do the different Lewis structure for polyatomic ions and for different molecules. But let us discuss what is the demerit of this Lewis structure. Okay, you can do drawbacks of Lewis structure. Drawbacks of Lewis electron dot structure. Drawbacks of Lewis electron dot structure. Molecules like, let us consider, if I consider BeCl2, beryllium chloride molecule. Is that clear? So Be, beryllium chloride, Be having how many valence electrons are there? Beryllium 2. And this chlorine, this one is, let's say, chlorine, and this one is chlorine. One Cl atom and another Cl atom, this is, and Cl having 5, 7 electrons in its valence shell, and one is here and one is here. Just see here, beryllium is associated with how many electrons? 2 to 4 electrons. No octet is there for beryllium, but the molecule exists, Cl and Cl. BeCl2, linear molecule, 180 degree bond angle. But here this BeCl2, this beryllium is less than octet. Okay, likewise if I consider BF3 molecule, here you see this is the central boron atom, and here one fluorine, another fluorine. Okay, so boron, how many valence electrons are there in boron? 3 valence electrons like this, and each dot electrons are given by this fluorine. Is that clear? Like this. So here you see boron is associated with 6 electrons, BF3, this one, the central boron is associated with 6 electrons, that is less than octet, but this molecule exists. So these are, since they are less than octet, such molecules are known as hypovalent molecules. And there are few molecules, other molecules you can see, these are called hypervalence molecules, that is above your octet configuration. For example, I am considering, let's say, PCl5. Tell me, this is central phosphorus atom having 5 electrons in its valence shell. 1, 2, 3, 4, 5. And Cl5, this one is 1Cl, 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 another Cl, and this one is Cl. Each are Cl. Okay, if you do their present their valence electrons, will be there, one here, one here, one here. Okay, so here you see phosphorus is associated with the how many chlorines? Cl, 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 Cl. 5. So it is associated with the 10 electrons, that is above octet. Next, if we consider, let us say, SF6, this is the central sulfur and fluorine. Then tell me how many electrons it is associated with? 12 electrons above octet. Then IF7, it is associated with the central iodine is associated with 14 electrons greater than octet. So what about all these molecules? These are called hypervalent molecules. These are called hypervalent molecules. Hypervalent molecules, because their valency above 8. Okay. Now, so these are the demerits of Lewis dot structure. That clear? Next, we will discuss coordinate covalent bond or coordinate bond. Simply you can say coordinate bond, or this is called dative bond. Dative bond. Very simple. Such type of bond, this type of bond is formed. This type of bond is formed between two species, out of which one having lone pair electron which donates to the atom which is deficient of octet for a pair of electron. Again, this is also called donor acceptor interaction. Okay, this is called donor and acceptor interaction. Donor acceptor interaction means I am considering a molecule ammonia. This is the structure of ammonia. This is the Lewis structure of ammonia. Is that clear? And here this pair of electron is not involved in bonding. That's why this is called a non-bonded electron pair, or you can say lone pair. Whenever we interact this ammonia with H plus, this is proton. This is ammonia and this is proton. Is that clear? Here you see this hydrogen having without its electron. That's why H plus. It need 2 electron for helium. So now this lone pair of electron is donated towards H plus. So here this ammonia, entire ammonia, this one is donor, while this H plus, that is your acceptor. Okay, so interaction can be written like this: NH HH and here H, but there will be overall positive charge because nitrogen has given its pair of electron to hydrogen, that's why it becomes electron deficient. So this is, here you can say which this species donate its pair of electron so that it act as Lewis base, and it accept the electron pair, so this is Lewis acid. Is that clear? Another example you can consider over here, that is interaction between ammonia and let's say boron trifluoride BF3. It has also, it need 2 electron boron for 8 electron. In order to having octet electron, this pair of electron donated to boron. So the interaction can be like this, NH3 BF3. So this coordinate or dative bond is assigned by an arrow. So this pair of electron, this is from donor side, this is towards acceptor. So I can write this structure, the structure of this one, NH3 interaction of here NH3 act as Lewis base, and this BF3 since it accept electron pair, so this is your Lewis acid. So this is one type of Lewis acid base interaction. Okay. Next we will discuss polarity of a covalent bond. Polarity of a covalent bond. Particularly the word polarity is applicable for heterodiatomic molecules. So heterodiatomic molecules means the two atoms are different. So different on the basis of what? They possess different electron negativity. As a result, the shared electron pairs get shifted towards more electronegative atom. So due to such shifting of electron towards more electronegative atom, what happens? There occurs charge separation. Positive and negative charge separation would be there. That means the more electronegative atoms having partial negative charge, while the other getting partially positive charge. Due to such charge separation, the bond is polarized and the molecule is said to be a polar molecule. Okay, so I can write over here a covalent bond which is formed between two dissimilar atoms having different electron negativity, is called a polar covalent bond. Is called a polar covalent bond. Okay, due to unequal electron distribution, there occurs charge separation. Okay, charge separation takes place between two atoms. One gets partially positive charge while the other gets partially negative charge. You see, suppose I am considering this one, but this molecule is homodiatomic, that's why this is non-polar. Why this is non-polar? Because due to same electron negativity, here electron negativity difference is 0. Electron negativity difference is 0. So this is non-polar. If I consider A, B, this is heterodiatomic molecule. So in this molecule, if I consider electron negativity of B is greater than electron negativity of A, two dissimilar atoms, so electron negativity should be differ. So what happens, since B is more electronegative than A, so these shared pair electrons are more attracted towards B. as a result the electron density at B will be maximum, so it gets partial negative charge and A gets partially positive charge. Okay, so that's why this AB is said to be a polar molecule. AB is said to be a polar molecule. Likewise, if I consider HF, here you see this fluorine is more electronegative, so hydrogen get delta plus and fluorine get delta minus. So this one is polar molecule. If I consider F, then tell me, due to similar atoms there is no electronegative difference between these two atoms. That's why this is non-polar molecule. Okay. Likewise, the main funda over here is there must be some two different or dissimilar atoms of elements should be there, so that the covalent bond can be polarized through your charge separation. Is that clear? So the concept here is more the charge separation or more the electron negativity difference, more will be the polarity, or more will be the percentage of ionic character, you can say. So how can I conclude over here? That is, more the electron negativity difference, more will be the charge separation, and more will be the polarity, or more polar will be the molecule. Okay, so likewise I can consider over here, if I compare this HF with HCl and HBr and the final one, that is HI, then tell me which one will be more polar, because here you know the electron negativity order, this fluorine is more electronegative than chlorine, is bromine, then it is iodine. So more charge separation will be where? At in case of HF. So I can mention like this, if it is the tendency of attracting electron tendency is fluorine, I can mention like this. In case of chlorine I can mention like this, 1, 2, 3, and bromine 1, 2, and iodine 1. Here you can get, so more charge separation will be here, then here. So polarity order varies like this, decreasing order of polarity. This is decreasing order of polarity. Is that clear? So this is the reason. Okay, next we will consider, that is dipole moment. Okay, simultaneously I want to discuss over here the very important physical characteristic, that is dipole moment. Just remember, this one is a vector quantity. This is represented like this. This one is dipole moment. So dipole means, what is a dipole? Two unequal charges having equal in magnitude but opposite sign. That means, suppose this one is plus q and this one is minus q, two equal and opposite charges separated through a distance r from each other, then this one is called a dipole. Is that clear? So if I consider HF, here this one is positive charge, this one negative charge, and having some distance, that is internuclear distance. This is called internuclear distance. Is that clear? So this one behaves as a dipole. So dipole, the funda over here is more the electron negativity. So I can, this dipole moment, value of dipole moment, this mu is given by the product of q into d. Q, that is charge. This one is charge of ions. Is that clear? And this d is the distance between them. Ions. Okay. So it's a product of a charge and distance. Dipole moment is defined as the product of a charge and distance. The product of charge and distance, that is called dipole moment, and it is denoted, its unit is dBA. dBA is the unit of dipole moment. Remember concept over here, that is more the electron negativity difference, okay, more will be the polarity and more will be the value of dipole moment. That clear? Again, this dipole moment value depends upon the structure of molecules. Why? Because as initially I have told you, this one is a vector quantity. So for vector quantity, so structure is most needed. Okay. For example, I am saying the carbon tetrachloride. Let's say carbon tetrachloride. This one is non-polar. Non-polar means, tell me the value of mu, that is equal to 0. How you see this carbon tetrachloride can be arranged like this: Cl, 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 Cl. Chlorine is more electronegative, so dipole interaction will be like this. Here this chlorine is more electronegative than carbon, so equal and opposite cancelled. So here this chlorine, so total net dipole force, the orientation of a dipole cancelling to each other, giving rise to mu, that is equal to 0. So this is non-polar. Again another molecule, let's say carbon dioxide beta, C double bond O. Oxygen is more electronegative, oxygen is more electronegative, again equal and opposite, mu becomes 0. So this is non-polar. That clear? Again let us consider few polar molecules. For example, in case of water, its structure is V shape or band shape, like this. This is the structure of water, and oxygen is more electronegative than hydrogen. So the dipole direction will be like this, and here the flow of electron will be like this. This is the, if you see during vector addition, these two vectors get oriented in this direction, so the net resultant will be in this direction, but there is no such force which cancel this resultant force. Okay, this is the resultant vector. There is no cancellation force over here, so it has some dipole moment, that is in case of water it is 1.84 dB. You see, next if I consider another molecule, that is SO2, let's say sulphur dioxide. What is its structure? Oxygen, again it also band shape structure, okay, having one non-bonding pair of electron over here. So here you see, out of sulfur and oxygen, more electronegative is oxygen, so the dipole direction will be towards in this direction. Okay, so if two vectors are in this direction, then the resultant force will be in this direction, but there is no cancellation of any force. But here the mu you are getting over here, that is 1.60 dB. You see, as the electron negativity difference decreases, so dipole moment also decreases. Again you can say another molecule, if I consider ammonia, you see nitrogen, hydrogen, it's pyramidal shape, remember. So this is a lone pair of electron over here. Here the dipole direction you can consider like this. Nitrogen is more electronegative, so dipoles are oriented in this direction. So three dipoles are oriented in this direction. The net resultant will be above, and this lone pair also. These are alignment parallel to each other. So no opposing interaction is there. So it has some dipole moment, that is 1.46 dB. 1.46 dB. So one thing is clear: more the charge separation, more the electron negativity difference, more will be the value of a dipole moment, and more will be the polarity. That clear? So today's class, it includes this much, and next class we will proceed further, that is involved in our topic. Okay, thank you.